Hello everyone. So we are at the last part of algebra. We are looking at sequences. So we'll be looking at AP, GP and infinite GP concepts. So let's quickly go through the ideas once. So what is an AP? AP terms are having a constant difference. So like 1, 3, 5, 7, constant difference of 2. Generalizing A plus D, then A plus 2D and so on. The nth term is A plus n minus 1D. And how do you find out the sum of the terms? So if you look at the series A, then A plus D, then A plus 2D, at the end it is A plus n minus 1D. If I write this in the reverse order, so this is A, then A plus D and so on, and last you will get A plus n minus 1D. And I add this, see what we get. 2s is equal to, so we add these two, that's 2a plus n minus 1d. And here also it will be the same, here also it will be the same, okay. So this will come n times. And hence the sum of the terms, the formula comes out to be n over 2, 2a plus n minus 1. Now this was an arithmetic sequence, AP, arithmetic progression. Geometric progressions are those with a constant ratio. So you can have 1, then double it and double it, or it can also be fraction. Like AP, you can have a negative also, right? For example, 10, then 9, 8, 7, 6. This is also an AP with a decreasing common difference. So here we can have a fractional common ratio also, it's like 16, 8, 4, 2, okay, like that. Or it could also be negative, like 16, minus 8, 4, minus 2. So common ratio is now negative half, okay, anything is possible. So here the nth term would be A times R is the common ratio to the power n minus 1. The general series would look like this, A, then AR, then AR squared and so on. And here the sum of n terms is A r to the power n minus 1 by r minus 1. Okay. How do we get this? So let us say we write S is A plus AR plus dot 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 AR to the power n minus 1. Multiply this with R and shift one place and write AR squared and AR to the power n. And subtract. All of these will cancel. So here S times R minus 1 will be A R to the power n minus A. So now you divide, we will get this. So we have the we have the GP series sum. Now there is something called an infinite GP. So the idea of infinite GP is we have the series same looking like this, AR squared and so on. Only this time that mod of R is less than 1. And this goes on to infinity. So everything remains the same except that the sum to infinity now is A by 1 minus R. So this is the infinite GP series, but this condition has to be satisfied. Okay, let's take some examples. So here this one says the natural numbers are divided into groups as 1, then 2, 3, 4, then 5, 6, 7, 8, 9 and so on. You have to find out the sum of the numbers in the 15th group. So first group starts with 1, second group starts with 2, third group starts with 5. Now where did this 5 come from? So the idea is so the first group has 1 term, the second group has 3 terms, the third group has 5 terms. So how we have to first figure out how many terms will the 15th group have, okay. So the number of terms in each group 1, 3, 5, 7, 9 and so on till T15. So first term, second term can be thought of as 2 times 2 minus 1, third term 2 times 3 minus 1, fourth term 2 times 4 minus 1, 15th term 2 times 15 minus 1. So 29 terms. This series will have 29 terms, the 15th set. Okay. One thing is done. Second thing is we need to figure out where does this, what number does this start with. Okay. So the first term starts with 1. The second term obviously has to start with 2. Now the third term which will start is 5. So how do we get to that 5? So basically the number of terms we have to have 1 plus 3 because these are consecutive numbers. So 4 numbers have been used up. So the next number will be 1 more than 1 plus 3. Okay. What will be the fourth term starting with? It will start with 10. So how do we know that it will be starting with 10? You have 1, 3 and 5 numbers used up. So the next term will start with the sum of these plus 1. So 1 plus 3 plus 5. See, this is how it will start with 10, 11 and so on. So 1 plus 3 plus 5. So 5 plus 3, 8 plus 1, 9, 9 plus 1, 10. That's what it starts with. So the T 15th term, if I want to figure out that set, what will it start with? So 1 plus 3 plus, this is the first term. Remember this sequence that we did. So 5 plus 7 plus 9 and so on. And here we had 29 terms. T14, if you look, that would have 2 times 14 minus 1, 27 terms. So till 27 we have to add 1 to that. So that will be the starting number. Okay. So how much is that? Here we are going to add up the odd numbers. And how many odd numbers? 14 odd numbers. Okay. We have to add 14 odd numbers. So now if you look, 1 odd number is 1. 2 odd numbers, if you add up, it's 4. 2 square. Okay. 3 odd numbers, if I add, it is 5 plus 3, 8 plus 1, 9. So 9. 3 square. 4 odd numbers, if I add, you get 16. 4 squared. 14 odd numbers, if I add, 14 square. 196. So 1 plus 196. So 197 is the starting number. So that means for T15, we have 197, 198, 199 and so on, and we have 29 of them. So what's the sum? 29 by 2, 2a plus n minus 1, so 29 minus 1 times d, d is 1 here. So that is our required sum. So let's calculate the value of this. So we have 29 over 2 times 197. So that is 394. 394 plus 28. So that's 29 by 2 times 30 will be 422. So that would be 211. Just a second. Okay, there's some glitch. Anyways, I'll rewrite this. This one's gone. This one is coming to 20. Just a second. I'll just remove this part. Okay, I'll just remove all this. So 29 by 2, this is what we had, right? Okay, let's write that again. So that's yeah, now it's back. Okay, 29 by 2, 2 times 197 plus we had n minus 1, so 28. Yes, this was the thing. We are trying to figure out the sum. So that was 29 by 2. So that is 394 plus 28, which we said is 29 by 2 times what was this? 12, 422. So that's 29 times 211. So it will end in a 9. So it has to be the third option, 6119. Okay, 6119. That is our answer. Let's go to the next one quickly. So we have the series S1 246 dot dot dot, S2 369 dot dot dot. Both have 100 terms. You have to find how many are common terms, identical terms. Okay. So this also came in CAT. So what is the series S1? 2, 4, 6 dot dot dot. Constant gap of 2. And series 2, 3, 6, 9 dot dot dot. Constant gap of 3. So what's the first common term? 6. And the common terms, here the gap is 2, here the gap is 3. So the LCM of 2 and 3 is 6. So this will continue in gaps of 6. So the common terms will be 6, then 12, then 18, like that in the two terms. Now, if they are continuing till 100 terms, now clearly this is very easy. 2 times 1, 2 times 2, 2 times 3. This will continue till 2 times 100. This will continue till 3 times 100. 3 times 1, 3 times 2, 3 times 3, 3 times 100. So obviously the common terms will end at 200. Anything which crosses 200 will not be common. So in continuing in groups of 6, the last number that will be divisible by 6 till 200 will be 6 multiplied with 33, which is 198. So 6 times 1, 6 times 2, 6 times 3 till 6 times 33. So how many are common terms? 2, 3, 4 till 33. So there are 33 common terms here. So that's the second option. I hope this was clear. Thanks for watching.